So in lesson 50, we're going to keep working with quadratic equations, and we're going to talk about one more way that we can solve these, and that method's going to be called completing the square. So remember, we're talking about equations that have an x square in them. That's what it means to be quadratic. And so far, the two methods that we've learned for solving quadratics are factoring. Maybe we have one like what you see here on the left, x squared plus x minus 2. Make sure it equals 0, get parentheses times parentheses, and get our answers. So in this case, x could be -2 and 1. This one started with 1x squared, so our parentheses started with 1x times 1x. We've also done ones that are harder with the AC method, where maybe we started with 6x squared. We didn't start with 1x squared, and we had a little bit more work to do, but we've also learned how to do those, but still by factoring. Parentheses, parentheses equals 0. We've also done the plus or minus square root method. If we can get something squared equals, including a parentheses squared equals, we take square roots of both sides and make sure we remember the plus or minus on one side. So x minus 2 is plus or minus root 3. Then we get x by itself. X is 2 plus or minus root 3. This is what we are going to try to get to today in our completing the square method. We want to get to parentheses squared equals so we can do the plus or minus square root. Before we're quite ready to do that, we need to review just a little bit about some polynomials. So this one is a perfect square trinomial. Trinomial just means it has 3 terms. Perfect square means I can write it as 1 parentheses times that same parentheses, not 2 different parentheses, not x minus 2 times x minus 1, but both parentheses are the same. Since this starts with a 1x squared, this will simply start with a 1x. Can anybody look at that and tell me what I need to put in that parentheses so that when I square it, I get x squared minus 4x plus 4? Evelyn? So it would be x minus 2 all squared. And I'm just curious, what was your thought process? How did you correctly come up with a minus 2? So you basically thought through all the steps of the factoring on that, right? Okay, we're going to see if we can see a pattern here in a minute. But first, let's take a look at this other one and see if we can do the same kind of thing with it. Can we write that as 1 parentheses squared? We know that since it starts with a 1x squared, the parentheses would have to start with an x. Can you look at that one and think for a moment and figure out what needs to go inside of there, Griff? So anybody else thinking x plus 3? And what was your thought process to get there? You're right. How did you think it through? Okay, so just basically kind of thinking through the whole factoring process again. Okay, now we want to look at this and see if we can see some patterns in it, because we're going to need those patterns for this method. So I had a minus 4 right here, and then I put a minus 2 over here. And we had a plus 6 right here in front of the x, and we put a plus 3 in the parentheses. Notice that the plus or minus sign stayed the same as whatever was in front of the x. But it also looks to me like if we started with a -4 and we needed a -2, we took half of that -4 and got a -2. Had to put the minus sign with it. Whatever the plus or minus sign was, we kept it there and took half. For this one, we took half of the plus 6 and we got a plus 3. So far, so good. Okay, then let's also notice that if we take whatever we put over here If we square it, 3 times 3, we get 9. Negative 2 times negative 2, so if we square that, do we get a plus 4? And also notice that that means this is always plus. Because if we take a negative and square it, it's positive, and if we take a positive and square it, it's positive. So are we good with that's how we factor these? Okay, now we're going to start off with a little bit less. Now I don't have a complete perfect square because I've got that blank in there. So I need to fill in the blank to complete that side so that we can do what we just did on the last slide. I need to figure out what goes in there so that I can also write this as a parentheses squared. Since this starts with a 1x squared, this is going to start with a 1x. Now we're going to use those observations I just gave you to figure out what we do. Remember what I said we do to the negative 10 to get the number over here? Griff, what do I do to the negative 10 to get the number in the parentheses? So we said we take half of whatever that is and put it in the parentheses. So if we take half, do you agree with what he just said, that we get a minus 5? And then to fill in that blank, what did we have to do to whatever we put in the little parentheses when we go back to the other side? Riley? No, I am not going to put square root of 5 over here. I need to square it. So to go back to the other side, I take whatever I put right here and I square it and fill it in the blank, so 25. So look at that, is x squared minus 10x plus 25 equal to x minus 5 times x minus 5? Give me thumbs up, thumbs down. That one makes sense. Okay, this next one I want you guys to try to do. So copy that much down into your notebooks. And then you're going to write that that equals some little parentheses squared. Since it starts with 1x squared, you're going to start your little parentheses with 1x. Your little parentheses is going to need to be x plus or minus something. You have to decide which. Remember those steps that you see. I'll go up enough that you can still see them. You take half, put it in the little parentheses, square it, put it back on the line. And Elias, have you done that already? So tell me first, what did you put in the little parentheses when you took half? Thumbs up, thumbs down for x plus 8. And Leah, when you square that, what did you put in the blank that we started out with? Thumbs up, thumbs down. Is that what everybody has? Okay, this last one before we actually start solving by completing the square is messier, so we're going to do it together with those same steps. We don't always get an even number in front of the x, so it's not always so easy to take half of it. But we're still going to go through the same steps. We want to get it as a parentheses squared. We start with 1x squared, so we know our little parentheses starts with 1x. We know we need to take half. And some of you, listen up. You're not going to like what I have to say, but listen and do it this way. I want you to use fractions. Do not use decimals, because it's going to be easier, and I'll explain why. I'm saying do this because it's easier for you. Trying to help you out here. The fractions can be improper or proper, but not mixed. If you want to do these the easiest way possible. So I am going to take half of the 5. I am not going to write plus 2.5. I'm not going to write plus 2.5. I am going to write it as 5 over 2. Now here you start to see why that's easier. Imagine you're doing this on a no calculator part of the test. 2.5, yes, I know some of you can square okay. Others of you sort of get it, but you got the decimal in the wrong place. Others of you are totally at a loss. If we, though, square that, we are taking 5 halves times 5 halves, and it's much easier to square a fraction. 5 halves times 5 halves is 25 over 4. Any questions so far? Okay, we're ready to start solving with this method. Question? No, you still have to write it as the plus 5 halves because you're going to need that. Because when we start solving, this is what we're going to need in our equation so that we can have that parentheses squared equals something, and then we can do the plus or minus square root method. And so you're going to want to have the 5 halves in there. You don't have to write down 5 halves squared. You can just write the 25 fourths, but you're actually going to write the 25 fourths twice, which you'll see in just a moment. So I'm going to go back and forth between these steps and an example. Some of you just need to copy the example carefully, making sure you get all the steps in there to be able to remember this. Others, just some of the key words out of this. You don't need to copy all of the words. If we get one that isn't factorable, we can use this method. We won't get it equal to 0. We'll get it equal to something else and then do the plus or minus square root method. So we're going to start with the 1x squared plus something times x on one side and anything else on the other side. So the x is on one side, anything else on the other side. So let's do that with this first example. Let's write that as x squared plus 6x, leave a space for what we were just doing on that last slide, equals 4. So far, so good. Evelyn? So all I've done is got the x's on one side and everything else on the other, but I've said leave yourself a little bit of room to do some work on it so your work's neater. Okay, then what we want to do is we want to get this side so it is that parentheses squared, and then we'll worry about the 4 in a little bit. So now we're doing, right, with this part what we just did. X squared plus 6x, we want 2 parentheses that start with 1x. To get that number, we take the plus 6, and we're going to take half of it, which is a plus 3. And then we're going to fill in, like we did on that last slide, what the other side would have been. We would have had x plus 3 times x plus 3. We would square this and put a plus 9 in here. But I'm trying to solve an equation now. I'm not trying to just get a completed square kind of line going here. I've got this equation. The real problem I'm solving is x squared plus 6x equals 4. When you have a real problem you're solving, is it okay to just do plus 9 on one side? When you have a real equation like what I've got up there in black, if you add 9 on one side, you better add 9 on the other side or you've changed the whole problem. So we need to also add a 9 over here on that side. You've got to show me that you're adding it on both sides. So going back to my steps, we have completed the square for the left. We took half of what was in front of the x. We wrote that in the little parentheses. Then we squared it. Then we added that to both sides. Now I've written the left side as that x plus or minus something squared. I've already done that. And now I still need to simplify the right side because I had 4 plus 9, and I can put that together and say that it equals 13. Now it's a problem you've done before. Parentheses squared equals a number. Emily, what do I do when I have parentheses squared equals a number? I do that plus or minus square root method. So we are going to take the square root and the square root and put a plus or minus in over here. So what we have now is x plus 3 equals plus or minus root 13. Brad, final step, what do I still have to do? No, I'm trying to get x equals. What do I need to do to have x equals? What do I have to do to have x by itself? Just got to subtract the 3 on both sides, and x is negative 3 plus or minus root 13. Is root 13 one I can simplify? Nope, so I can't put it together with a negative 3. I can leave those two answers written with a plus or minus sign. And if I go back to my list of steps, after we simplified the right side, we took the square root of both sides. We remembered the plus or minus, and then we solved until we had x by itself. And that's the completing the square method. I want to do one more example with you guys, and then it'll be work time. So first we have to get the x's on one side and anything else on the other side. So we start out copying this from the book as x squared minus 9x, leave our space, equals negative 7. I needed to move the 9x to the other side. The other two things stayed where they were. So the 9x is the only one that changed, whether it was a plus or a minus sign. Then the next step was get our little parentheses that's squared. We need to take half of minus 9. Am I going to write it as minus 4.5? Minus 4.5. Not going to use decimals. We're going to write it as minus 9 over 2 so that it is easier to square. When we square it, we put it back in that original line. Will it be plus or minus? Negative 9 halves times negative 9 halves will be plus. 9 halves times 9 halves, 81 over 4. Is it okay to have my original problem, x squared minus 9x equals negative 7, and just add 81/4 on one side? So we've got to show that we're adding it on both sides. So we have the left written as parentheses squared. Now we need to simplify the right, which means we need a common denominator. So be careful with your arithmetic when you're doing these. You need a common denominator of 4. So we need to multiply by 4 over 4. So I have negative 28/4 plus 81/4. That give me 53/4. Did I do that right? So this equals 53 over 4. Parentheses squared equals. Grayson, what's my next step? And what do I have to be sure I remember? Perfect. Don't forget the plus or minus. So now what we have is x minus 9 halves equals plus or minus the square root of a fraction. Can I leave a square root of a fraction? No. I've got to do square root of numerator over denominator, and sometimes rationalize the denominator. So in this case, I am looking at plus or minus the square root of 53 over the square root of 4. But we know the square root of 4 is what, everybody? So I have my plus or minus root 53 over 2. What do I need to do to have x by itself? Add 9 halves to both sides. So that becomes a plus 9 halves over here. You may leave it like that. No square roots and denominators. Or you may write it with one common denominator. Can we simplify root 53 at all? Nope. So we can't put it together with a 9. Sometimes you'll get a square root, you can simplify some more and you need to reduce it. But in this case, these would be our final answers. Now, my last caution for you guys, when you have something like root 53 over 2 and the square root is just in the numerator, be sure your square root sign looks like it is just in the numerator. Do not write it where it is kind of looking like it's also including the denominator. Make it very clear. Whereas up here, yeah, I made sure I had it come all the way down so you could tell this one was square root of the whole fraction. So be nice and neat with that or you'll confuse me and you'll confuse yourselves. Any final questions before we have our work time?